Hello, wonderful, amazing, fantastic algebra students. This is Miss Youngblood here, bringing you today's video review, which is going to focus on the first session of the factoring unit, which is called Introduction to Factoring. So let's hop into it. If you go to Google Classroom, again, you're looking at Content Week, May 18th through 22nd. The unit title is Factoring, and we're focusing on the first session in this video, Introduction to Factoring. We're going to hop on to Khan Academy. If you click that link, it should take you straight to your Khan Academy page. You should already be logged in. If not, make sure you're logged in with your school email, whatever email that you use to sign up for my Khan Academy class. And also make sure you are in the correct class. So we're in algebra right now. We should be looking at our algebra assignments. And the first assignment I'm going to go through with you guys is GCF Factoring Introduction. The assignment is only 4 problems, so let's start with the first one. I'm going to copy this over to my sketch pad, and I will be right back. So here's the problem that was in Khan Academy. As I said in the introduction to this video, we're focusing on factoring. You can think of factoring as the opposite of distribution. So just like addition and subtraction are opposites, multiplication and division are opposites, factoring is the opposite of distribution. So we are basically trying to figure out what was distributed to get this quadratic or polynomial expression. To jump into that topic, I think it would be meaningful to review distribution again. And I'm going to use the area model to show the distribution because it's going to make it a lot easier for us when we start factoring more challenging problems. So if we were given this expression to multiply, so we have 2x cubed, so we would put the 2x cubed here, and we have x squared plus 5x, so we would put that up here. You can distribute it the way we learned in school, or you can distribute it the way we've been learning online. The way we've been learning online is using the area model. So to find the area of this square, we're going to multiply the 2x cubed and the 2x squared. So the multiplication that we're doing is 2x cubed times x squared. That 2 is just going to stay there because there's nothing to multiply by the 2. There's no other coefficient. You know there's a 1 in front of this x squared. 1 times 2 just gets us 2. But now we want to figure out how many x's we have. So we have 3 x's here because of this exponent and 2 x's here. Again, just a reminder from 2 weeks ago. This means that we have x times x times x. And this means that we have x times x. Again, that's coming from the 2 exponents that we see. So altogether, we're going to have x to the 5th. We just add the exponents. So this first box is going to be 2x to the 5th. And this second box is going to be 10x. And if we count how many x's we have 3 x's here and 1 x here. So it's going to be 10x to the 4th. So that's how you would distribute if we were given something like this. But now we're factoring. So factoring is, like I said, working backwards. We're given what's on the inside, and we have to figure out what was multiplied to get that. So let's draw our boxes again. So we have these boxes because we have 2 parts or 2 terms separated by addition or subtraction. In our first box, we're going to put the x squared or the 8x squared. In our second box, we're going to put the negative 24. So we have 8x squared minus 24, and we're trying to figure out what was multiplied to get that. To do that, you want to find the greatest common factor between the 2 numbers. So what is the greatest common factor between 8 and negative 24? Because I've been doing math for a long time, I know off the top of my head that it's 8. 8 is the biggest number that goes into 8 and 24. Some of you might see how I've gotten that. For those who haven't, the long way you can do it to kind of make sure you don't miss any possibilities is to list the factors of the smaller number. So what are the factors of 8? What numbers do we multiply to get 8? We know the factors of 8, but we know we can do 1 times 8, right? 1 times 8 is 8. We also know 2 times 4. Oops. Not 48. Right? 2 times 4 is 8. And then 3 isn't going to work, so we're not going to add 3. So these are the 4 factors of 8. 1, 2, 4, and 8. To find the greatest common factor, start at the biggest number. Our biggest number is 8. We obviously know 8 goes into 8 because it's a factor, and we know that 8 goes into 24. If we didn't know that off the top of our head, you could check it in a calculator. So in your calculator, you would do 24 divided by 8, and you would get a whole number, which means it's a factor. If you need more help with factors, I know Khan Academy has a lot of examples on how to find greatest common factors, or you can reach out if you're struggling with that part. Regardless, the greatest common factor of 8 and negative 24 is 8. Now we want to see if we can factor out any x's. We can't, because there are no x's here, so we cannot factor out any x's. So that means our top portion is going to be x squared, right? Because 8 times x squared is 8x squared, and this portion here is going to be negative 3. And again, that's because 8 times negative 3 is negative 24. If you didn't know this off the top of your head, you could have just, again, divided negative 24 and 8 to get that negative 3. So our final answer for this first problem is going to be 8x squared minus 3. And that's what you would select on the multiple choice. This is the next problem in my Khan Academy set, and I want to actually read how it was worded on Khan Academy. So it says, Avery was trying to factor 4x squared plus 20x minus 16. She found that the greatest common factor of these terms was 4 and made an area model. So again, she's factored out 4 because that's her greatest common factor. She put in the 3 terms that were given, 4x squared plus 20x minus 16. And now the only work we have to do is figure out what is on the top of this area model. So if we factor out 4 from this first term, we're going to be left with x squared, because we didn't factor out any x's, and 4 divided by 4 is 1. If we factor out 4 from the second term, we're going to be left with, actually, I'm going to move them down here so you guys can see them. So it's x squared. This will be 5x. And again, that's because 20 divided by 4 is 5. And this is going to be minus 4. And that's because negative 16 divided by 4 is negative 4. So this is going to be the width of the area model. In this next problem, we are asked to factor this quadratic expression. So again, we want to draw our area model. And for this problem, we have 3 terms, just like our previous problem here. So we're going to need 3 boxes. So we'll draw our area model. 1, 2, 3 boxes. In our first box, we're going to put this 4x squared. In our second box, we're going to put 16x. And our third box will be negative 4. So again, we're looking for the biggest number that goes into 4, 16, and negative 4. So I'm going to look at my smallest number and think of the factors. The greatest factor for 4 is the number itself, 4. And that number happens to go into itself and 16. So we're going to factor out 4. For this particular problem, again, we cannot factor out any x's because this last term does not have an x. So if we factor out 4 from this first term, we're left with x squared. Again, that's because 4 times x squared is x squared. In the second term, we're going to be left with 4x. Again, 4 times 4x is 16x. In this last term, we're going to be left with negative 1. So that's because 4 times negative 1 is negative 4. So our final answer for this problem is going to be 4 times x squared plus 4x minus 1. And this is going to be our last problem in the set, which is very similar to this one. We're given the quadratic expression or polynomial on the inside. We're given what was factored out, and we have to figure out the width or the remaining polynomial that's up here after you factor out 2. So if we look at this first box, 6x squared divided by 2, 6 divided by 2 gets us 3. No x's were factored out, so we still have that x squared. 10 divided by 2 gets us 5. And again, if you wanted to check it, let me write the remaining polynomials. So we have 2 times 3x squared plus 5. If you wanted to check it, you could distribute this 2 into the parentheses and make sure you get the same expression. 2 times 3x squared is 6x squared. 2 times 5 is 10. So that means we did this one correct. I do want to emphasize that for this particular problem, they are only asking for the width. So make sure you are only typing in this part, this 3x squared plus 5. Same thing with this problem. You should only be typing in x squared plus 5x minus 4. If you type in this first part, it's going to be wrong. That was our last problem in that set. So now let's look at our second set in this session, which is factoring quadratics intro. If you click on that set, again, you only have 4 problems, and we are going to factor this quadratic expression into 2 binomials. So that means you're trying to figure out what two-termed polynomials were multiplied to get this x squared minus 9x plus 20. So we're going to add this to our sketch pad and go from there. So again, for this first problem, we're being asked to factor this quadratic expression. So we're being asked to figure out what 2 binomials were distributed to get x squared minus 9x plus 20. And we're still going to use our box method to help us organize our information and figure that out. Let's kind of visualize what we're actually doing here. So this is what we were used to getting for our final answer, but now we're working backwards. So normally in the step before, you would have x squared plus some term with an x plus another term with an x plus 20, right? We normally have to combine like terms and we're multiplying. And to get these 4 terms, we have to multiply 2 binomials. So we have x plus or minus something times x plus or minus something. And we'll figure those out in a moment. So right now we'll just put plus signs and we'll change them after if we have to. So remember, when we're normally distributing, we have our first term, x squared, ends up going here. And our last term, 20, ends up going here. We have to figure out what are the 2 terms that we combine to get negative 9x. So those 2 terms will go here. We're trying to split this negative 9x between these 2 boxes. There are a whole bunch of numbers we can combine by addition to get negative 9. We could do negative 29 and 20. We could do negative 10 and 1. But what limits that possibility is that we have to find numbers that multiply to get us this 20. And this is called the AC method. I want you guys to get in the habit of thinking of it as the AC method because it will be helpful to us when we get to harder problems in our next session. So the AC method involves multiplying the A, the coefficient of the first term, times the C, the constant term, the term without a variable. So again, we're going to do A times C. So 20 times 1 just happens to be 20. So this is our focus number. We're looking at 20. So remember, these 2 numbers have to multiply to get us 20. So we want to think of all the numbers that multiply to get us 20 and add to get us negative 9. So there aren't that many numbers we can multiply to get 20, but there's only one pair of numbers that will multiply to get 20 and add to negative 9. So let's think about the factors of 20. Again, if you don't know off the top of your head, you can go through this process. We have 1 and 20. Can we combine 1 and 20 in any kind of way to get negative 9? No. We have 2 and 10. We're on the right track. 2 and 10 are kind of close, but again, you can't combine them to get negative 9. We have 3, so 3 doesn't go into 20, so we're going to skip it. But we have 4 and 5. 4 and 5 multiply to get 20, and we can combine 4 and 5 to get 9. 4 plus 5 is positive 9, but again, we want our answer to be negative 9. If we make them both negative, so if we have negative 4 and negative 5, 2 negatives when multiplied make a positive, so that gets us our positive 20, and when we add them, we get negative 9. So those are the 2 numbers that we're going to use to factor. So again, we're splitting this negative 9x into negative 4x and negative 5x. So all we did was break apart the negative 9x into 2 terms so that we can factor it into this polynomial into 2 binomials. So now we're going to do what we were doing in the previous session, factor out the greatest common factor. So it's always easiest to start with one of the rows and then all the other terms kind of fall into place. So if we just look at these two terms in this first row, what can we factor out? Can we factor out a number? We can't. There's a 1 here, so we can't factor out any number. But can we factor out some variables? Yeah, both terms have x's, so we can factor out an x. And now let's see what we have left at the top here. If we factor out x, we're going to have x left. To check that, we see x times x is x squared. If we factor out x from this term, we're going to have negative 4 left. To check that, we would do negative 4 times x is negative 4x. We do the same thing down here. So we already know this has to be x, and this has to be 20. So the only option for this space right here would be negative 5. Negative 5 times negative 4 is 20. X times x is x squared. X times negative 4 is negative 4x, and negative 5 times x is negative 5x. So again, if you wanted to see that in the long way, or how we were used to doing it 2 weeks ago, we would have x plus negative 4, which is the same thing as x minus 4, times x minus 5. That would have gotten us x. Let me make it in orange, might be easier to see the connection. So it was minus 4 minus 5. So we have x squared minus 4x minus 5x plus 20, which gets us this negative 9x in the middle. So these are the two polynomials or binomials that were multiplied to get us x squared minus 4x minus 5x. So that's going to be the answer that we write down. Our final answer is x minus 4 times x minus 5. So again, for the rest of these problems, I'm not going to be showing all this. I'm just going to be showing the box method and how to get that outside. But I really wanted to make sure you understood the process. So let's go to the next problem. The next problem in our set is somewhat similar to the problems in the previous set, where they give us what's on the inside, they give us part of what's on the outside, and we have to figure out the other part. So let's rewrite this so that we can clearly see where these terms are lying, and where we will be better able to figure out what the width is going to be. So we draw our box, label what we have on the inside. So on the inside it says we have x squared, we have 30, and we have this x minus 5 here. So we actually have enough information to figure out what these two terms have to be and figure out what the width is going to be. So if this is negative 5, or let's start here, sorry. If this is x and this is x squared, this has to be x. Again, that's because x times x is x squared. If this is x and this is negative 5, this term has to be negative 5x. If this is negative 5 and this is 30, this has to be negative 6. And again, that's because negative 6 times negative 5 is 30. You can always double check what's on the outside by multiplying and making sure you're getting what's on the inside. This last box is negative 6 times x, which is just negative x. So again, if you wanted to check it, x times x is x squared, negative 5 times x is negative 5x, negative 6 times x is negative 6x, and negative 6 times negative 5 is 30. So our answer, what they're asking us to find, is the width. So that's the binomial that we weren't given, which in our case is going to be x minus 6. Final answer for this next problem is x minus 6. In this next problem, we have to factor this expression, x squared minus 3x plus 2. So again, we're going to set up our boxes. So set up our boxes like so. And we're going to plug in what we already know. So we have x squared, we have 2, And now we're trying to break apart this negative 3x between these two boxes. There are a lot of ways we could break apart negative 3x, but there's only one way that we can do it for this particular problem. And remember, that depends on the AC method. So this is our A, this is our C. So we're looking at 2 times 1, which is 2. We want two numbers that multiply to 2, but are going to add to get us negative 3. There is only one pair of factors for 2, and that's 1 and 2. In order for them to add to get us negative 3, they both have to be negative. So we would do negative 2 plus negative 1 is negative 3. So again, we're going to split this negative 3 into negative 2x and negative 1x. And now we're factoring. So we have x and x. If this is x here, negative 1 has to go here. This is negative 1, negative 2 has to go here. If you want to check it, you would do x times x is x squared. X times negative 2 is negative 2x. Negative 1 times x is negative 1x. And negative 1 times negative 2 is 2. So the two binomials that were multiplied to get x squared minus 3x plus 2 were x minus 1 times x minus 2. Our last problem in this set, again, gives us the polynomial, gives us one of the factors, and we have to find the other factor. So let's plug in what we know. We know the inside, we have x squared and negative 12, and we're told that the top of the rectangle has to be x and 2. So again, if we have x here, this has to be x. X times 2 is 2x. 2 times negative 6 is negative 12. And negative 6 times x is negative 6. So I just work backwards, and I can verify quickly with multiplication. X times x is x squared. X times 2 is 2x. Negative 6 times x is negative 6x. Negative 6 times 2 is negative 12. So that's how you verify to make sure the inside of the box is correct. Again, you can see negative 4x here between negative 6x and 2. Negative 6 plus 2 gets us negative 4x. So now we just have to write our final answer. Our width, the factor we were not given, was x minus 6. So that would be the answer we would put for that last problem. X minus 6. Again, that was our last problem. And that actually completes this first session. So again, for this session, you only have to do those two problem sets, and I'll be posting this video on YouTube and in Google Classroom. Thank you so much for taking the time to watch. Make sure you complete the weekly check-in if you haven't already before Monday. Those are points that help your grades. And just make sure you're reaching out if this video is still confusing, because sometimes you need that one-on-one help. If you have any questions outside of, completing the Khan Academy assignments about your grades or whatever, you can always reach out, text, or email me. Again, thank you for taking the time to watch this video, and I hope I see or hear from you soon. Bye.